Hi, my name is Mike, Technology Manager at Restoration Robotics. In this short 8-minute video, I'll walk you through the various steps of the ARTAS procedure. To begin, we need to prepare the donor area, and we'll start by marking out the region from which follicular units will be harvested by the system. Next, the donor area will be shaved down to a length of 1 millimeter. 1 millimeter is the optimal length for the system to identify, track, and dissect follicular units. Next, the donor area will be anesthetized. The patient will now be brought into the room with the ARTAS system and seated in this chair. This chair was designed for two purposes. First, to provide comfort for the patient throughout the case, and position the patient's donor area in the optimal position for harvesting. With the patient seated comfortably, the ARTAS skin tensioner will be installed onto the patient's donor area. The ARTAS skin tensioner is designed to create traction in the area of harvesting. The straps provide the patient with a friendly reminder not to lift their head, and the fiducial markers enable tracking of harvested sites. With the touch of a button, the operator positions the robotic arm over the back of the patient. The computer side operator will now position the virtual skin tensioner on the virtual head. This allows them to quickly track areas that have already been harvested, as well as plan ahead for the next area. By holding down on a button on the ARTAS pendant, the patient side operator drags the system into position. Two lasers help the patient side operator locate the system. When the dots overlap, the system is in focus and no longer needs to be moved. With the touch of a button, the system will register the fiducial markers located at the edges of the skin tensioner. This process is key to the system's ability to track already harvested follicular units, as well as automatically select the next follicular unit to be harvested. After registration is completed, the system will position itself in the lower left-hand corner. The operator simply selects a follicular unit and harvesting begins. Patient movement is inevitable, so the system was designed to track and compensate for patient movement continuously and automatically. The selection process is automatic. However, it can be overridden at any time by either the patient side or computer side operators. For maximum situational awareness, both the computer side and patient side operators have a display on which to monitor the dissection process. Safety is paramount to the ARTAS system. One of these features includes a sensor at the bottom of the needle mechanism. If this sensor detects patient contact, the system automatically retracts the needles and elevates away from the patient. To the human eye, this appears to be a very bright red light. However, to the ARTAS system, these red lights significantly enhance the view for the cameras and image processing systems. The patient side operator utilizes a pendant. This pendant provides controls for the workflow we've just described. The pendant also can be used to adjust dissection parameters during harvesting. To enhance efficiency, grafts can be extracted while the system is harvesting. The system provides sufficient clearance for use of the 2-forceps extraction method. In the next section of the video, I'll talk about some of the automated dissection features of the ARTAS system. There are 4 parameters controlled by the automation system. They're indicated in the lower right-hand corner of the screen. They're known as PD, CD, angle, and RPM. First, let's look at PD. PD stands for puncture depth, which is the depth of the sharp inner needle, the first needle to enter the scalp. There are marks on the outside of this needle, as you can see in the upper right-hand corner of the screen in the still image. The system tracks these marks and automatically maintains the desired depth set by the user. The user simply sets a depth and the automation maintains it. Next, let's look at the CD parameter. CD stands for coring depth. This is the depth of the dull dissection punch that enters the skin after the sharp needle enters it first. The point at which the punch enters the skin fully is detected automatically by the system. The user simply sets the desired penetration and the automation system maintains it. Next, let's talk about RPM. RPM is the rotational speed of the dull dissection punch. Each time the dull dissection punch enters the skin, the force required to do so is measured. If a higher resistance is detected, then higher RPMs will engage automatically. The final automation parameter is the harvest angle. To begin, the emergence angles of all the visible hairs are averaged together. The system automatically adjusts the harvest angle based on this information. The user simply controls the offset added to the measured average. The offset plus the measured average becomes the harvest angle. Yellow arrows below each of the 4 automation parameters in the lower right-hand corner indicate that the system has adjusted a parameter automatically. Harvesting is complete when no eligible hairs are in view. The system always makes smooth and controlled motions. Immediately following the completion of this skin tensioner region, work begins on moving the skin tensioner to the next location. While this is happening, the system will automatically flush the suction system with saline. And that concludes this ARTAS procedure case example.